So we're now on page 3. So when I look here, the reason why I don't like it is because you can't have a radical in the denominator. But the nice thing about this one is the square root of 36 is 6 times 2 is 12. If you look, there's nothing in the denominator that's 12, and that's because you can tree the 20. 10 and 2, 2 and 5, circle the doubles. The doubles go on the outside. What's left goes on the inside. 2 goes into 12 6 times. Rad 5 over 6. The answer is C. All right, number 20 is similar to a problem on the second page where I have to multiply by the conjugate. Negative 2 plus rad 3, negative 2 plus rad 3. I'll start with the numerator. So I multiply the outside numbers, rad 3, and then I multiply this. Now rad 3 times rad 3 is 3, times 5 is 15. So my numerator is 15. I'm going to box out the bottom. Negative 2 minus rad 3, negative 2 plus rad 3. Now remember, the goal of this is to make the radicals go away. So that's negative rad 3 times rad 3 is 3. Okay. There's no imaginary numbers. That was the previous page. Now 4 minus 3 is 1. And anything over 1 is itself. All right, let's do the next one, solving it. There's probably a couple different ways to solve this, but the way that seems easiest to me, because it's just an x squared, is to solve for the x squared. Oops, I'm sorry, you can't see that. Now square root, plus or minus. I already did rad 20 up there, which was 2 rad 5. One's positive, one's negative. That can't be it, because you have to have two answers unless they're the exact same answers. Okay, so for this one, you've got to set it equal to 0. So if I take this and I set it equal to 0, minus 1, divide by 3, negative 1/3 is one of mine, which is all those, that doesn't help. If I set this equal to 0, this is a little bit more complex. Minus 1, 5x squared equals negative 1, divide by 5. This one's going to be a little bit of a workout. This one's a little bit of a workout because when you square root, you're going to get imaginaries. So that means that I know that one's out. So the square root of 1 is 1, and the square root of 5 is the square root of 5. You can't have a radical in the denominator, so it's rad 5 over 5, but the negative means it's imaginary. So I'm looking for I rad 5 over 5. That's out. Okay. And then I want to take this x squared minus 3. Move this up. I'm going to solve that right here. X squared minus 3 equals 0, plus 3 plus 3. X squared equals 3, square root, plus or minus rad 3. So there's no more imaginaries. So my answer is C. Okay, let's go to number 23. So they're asking us to plug in 1. So it's 4 to the 1 minus 1 minus 2. 1 minus 1 is 0. Anything to the 0 power is 1. And 1 minus 2, negative 1. I would say be careful. I'm worried you're going to forget this negative 2, and then you're not going to find the answer at all. Okay. As a side note, if you ended up with 4, 1 minus 2, and it's 4 to the negative 1, that means it's going to be a fraction. And your calculator can help you with that. Number 24, we recently did this. So remember, it's got to equal that squared. So it can't be 16, that's out. Do the opposite. So the opposite of negative 13 is positive 13. The opposite of positive 14 is negative 14. So it's D. For this one, I'm going to solve for x, distribute. So I end up with 6p plus 24p minus 40 equals 195. Put the same together. 30p minus 40 equals 195. Add 40. 30p equals 235. And I must have made a mistake. Oh, 3 times 5. Let's make that 15. Something all of you probably caught in the beginning. I am definitely going fast. Let's make that 210. Divide by 30, divide by 30. Zeros are gone. 21 divided by 3, 7. Okay. Last one on the page. Multiply. Negative 3 rad 12, because the radicals multiply. And then minus 6 rad 6. You don't see the answer in there. You don't see the answer in there because you can tree the 12. 2, 6, 2, 3, circle the doubles. So rad 12 is 2 rad 3, but then I have the negative 3, so I multiply it, negative 6 rad 3 minus 6 rad 6. And my answer is C. Again, I don't think you will disagree that it's not difficult, but it's just a lot of information. Page 3, done.